Well, welcome everyone. I'm Alison from the Southern Cross Postgraduate Association. Very pleased to see you all here and happy to introduce this workshop with Dr. Megan Lee, Introduction to Statistics and SPSS. As you may have noticed from when you registered, it's a series of 4 workshops. It's going to run every Wednesday. So next Wednesday, the following week and the following same time, 10:30. So I'll put the registration form in the link again, but many of you may have actually signed up for all 4, I'm hoping anyway. Yeah, so I'm recording and I will post the recording out afterwards to everyone that's registered. So welcome, and let's get into it, Megan. Thanks.
Thank you so much, Alison. Hello, everyone. I'm Dr. Megan Lee. I work at Bond University on the Gold Coast. However, I am an alumni of Southern Cross University. I finished my PhD in June of last year, so pretty new. I have a bachelor's in psychology, and one of the benefits of doing a psychology degree is that you get a lot of training in statistics. So I now teach statistics. I teach Stats 1 and Stats 3 here at Bond, as well as lots of research methods units. So even though maths was not my best subject at school, and stats was probably not my best subject in uni, it became part of my career, which is pretty interesting. If you do want to follow me on any of the socials, I'm Megan Lee PhD on my Twitter. That's more of a researchy place where I talk to people about my research. Instagram and Facebook is lots of fun food and mood pictures and things. So my PhD is in nutritional psychiatry, and I'm all about nutrition and mental health. So if you're interested in the types of foods that are good for your brain and some awesome recipes and fun food facts, follow me on Instagram or Facebook. My website also is www.meganlovingmeagain.com. This slide will be at the end as well if you like what you see today. But we are basically here today to talk about statistics. As Alison said, we will be, over the next 4 weeks, diving into statistics and the software platform SPSS. I'm also hoping that in the last couple of weeks, we might have time for me to show you some of the other platforms that are online now that don't require cost. So SPSS is a fully paid licensed software, but Southern Cross University pay that for you if you are a student. So you can access that at any time through the software center. Just talk to IT, they'll download that for you. But there are other online statistical software programs now that are just as good as SPSS, like JASP and Jamovi, and I'll take you through those in the last couple of weeks if we get time. Today, we will be looking at an introduction to statistics and SPSS. So this is one that we do when we assume that you have little to no understanding of SPSS. You've never been in there before. You've never seen what it looks like. And then moving on next week to intermediate, which is where we will start analyzing descriptive statistics and doing some easier inferential statistics. We'll go into the differences of those 2 different types of statistics in a second. And then the 2 advanced courses in the final 2 weeks will be going into more advanced statistical analyses. I'd really like to show you hierarchical regression and ANOVAs, but I will possibly poll everybody and see what everyone will be doing and needing help with. So if you're doing a factor analysis or something like that. So at the end, we might have a chat to everybody and see what sort of analysis would be helpful for you to learn in those final advanced weeks. All right, so to begin with, let's see in the chat box. I just want you to pop in there from 1 to 10, with 1 being the least amount, or 0 even, 0 being no statistical experience and no experience with SPSS, all the way up to 10, I'm an advanced expert at SPSS. But type in between 1 and 10 where you sit on that continuum. Oh, good. All right. So we have a wide range of abilities here. So that's sometimes tricky to teach too, but it's okay. So we've got a fair few zeros, so no experience in statistics and SPSS. That's excellent. That's what this workshop has been aimed at. But for those who are at 4s, 5s, and 6s, it might just be a really good revision of what you already know, but stick around because I'm going to also teach you some tips and tricks inside SPSS that can make your life a little bit easier as well, while we're going through how to use SPSS. There's lots of little things that I've learned over time that make using the platform easier, and I'll show you those as well. So you might pick up, even if you have a fair amount of experience, you might pick up some really good stuff today. But the intermediate and the advanced courses will be more up your alley, I would assume. Well, maybe now I will actually ask you, instead of waiting to the end, because I will probably forget, what analyses, type into the chat box whether you're a PhD or a master's student, what project you're working on, the name of your project, and what analyses would you like to see me cover during this course? Which one do you need the most help with? So I'll go through that again. Whether you're a PhD or master's, or what course you're doing, what project you are working on, or what your research question is, and what analysis would be most beneficial for you to learn throughout these 4 weeks. Just letting everybody type.
And we've got honours students as well.
Ah, excellent. So honours students who are doing a thesis?
I'll let Henriette answer that. She just posted that she did pass statistics in her honours. So
Okay. So the honours psych students will be doing a thesis.
yeah.
Which is good. So it looks like most of the honours are psych students.
Yeah.
Christopher, PhD, clinical trial, regression and reliability analysis. Good. Okay, I'm going to write these things down. Regression is definitely happening in week 3. So I'm glad we are going to, people are interested in that. Reliability, which is something we do usually within a regression to just make sure that the scales that we are using are reliable in the population that we are using them in. So that's definitely something that we can do. That's Crombax Alpha. Just a confusing name to make things tricky for us all. What have we got? Honours Psych. We've got lots of Honours Psych. Wanting a refresher. Excellent. Honours Psych. Correlation and regression. Excellent. We will also be doing correlations. Correlations will happen next week. Yes to thesis. Okay. Zoe's moving towards masters. Not sure what analysis she'll need. In our PhD clinical trial on medicinal cannabis and fibromyalgia. That's really cool. So maybe in a clinical trial, you'd be looking more at differences between groups. So that would be ANOVAs or t-tests, I'm assuming. So we'll be doing t-tests next week and ANOVAs the week after. Latent profile analysis. So Albie wants latent profile analysis. That's a factor analysis terminology, I believe. Hopefully we can look at that. Oh, Louise, PhD case study, not sure what would be best for interview findings, if any. So Louise, if you didn't attend my workshop from 2 weeks ago on qualitative research. Alison has the recording up on YouTube already. Is that right?
Yes, I do.
If you want to just find that and pop that in the chat box,
Will do.
Louise, if you want to review that, we talk about the analysis. We talk about reflexive thematic analysis for interview findings in that workshop. So have a look at that. Deb, simulation-based interprofessional education using mixed reality. Wow, very cool. Several different quant surveys tools to run through SPSS. Okay, perfect. You'll definitely get a lot out of these workshops. Shorebirds and use of technology for monitoring for Zoe. Correlation. Good. Oh, Alice wants some information on how to put the stats into words, like interpretation of the output. We can definitely do that when we move into the inferential statistics in weeks 2 and 3. I'll put a little bit about interpretation on each one. Inner wants ANOVA's logistic regression. Okay. So logistic regression is just a regression when your IVs are, no, your DV is dichotomous. So there's 2 choices, like depressed and not depressed. So maybe if we have enough time next week in the third week on regression, I'll do a little bit on logistic regression at the end. Chi-square.
How are you going? Yeah, not too good.
Maybe mute everyone, Alison. Thanks. Regression. Would like to check with you that I'm choosing the correct analysis. Okay, Henriette, that's good. There is a very fun website where you can type in what your variables are and whether they're categorical or continuous, and it will tell you which analysis you should use. So I'll teach you how to do that too. So I will write that down. Okay, so Louise was at the qualitative methods. Yep, so the book that's at the end of that workshop by Braun and Clark called Thematic Analysis, A Practical Guide. Louise, I would highly, highly recommend getting that. It doesn't cost very much. It's kind of like $30 because it's not a big textbook, but it will step you through from the very beginning of designing your research in interview studies all the way to the end report writing and all the analysis in between and what you should do. And yeah. Great. Okay, perfect. So we will be covering all of those. Which book? It's called Thematic Analysis, A Practical Guide by Braun and Clark. But it's for people who are doing qualitative data analysis, not quantitative. Yeah, the papers are amazing too, Louise. Excellent. Good. All right, let's move on then. Right. So today we are covering designing our research, which is really important, levels of measurement. So understanding what the levels of measurement are is imperative before you try and analyze in SPSS. Cleaning your data. We're going to talk about a little bit about how to reverse code scales and transform our variables. So that's what we will be doing today. So what's really important before you analyze data? And this is something that I have seen quite a bit with PhD students and master's students who come to me with data that they've collected. And they say, Megan, can you analyze this for me? And I have a look and I realize that the data is not analyzable. So it's really, really important to have the map of what you are going to do in your head of your data analysis before you collect your data. Otherwise, the questions in your survey or the way that you design your experiment could potentially make your data not analyzable. So there are different types of research design, descriptive designs like our interviews and our focus groups, and that's qualitative. We won't be touching on qualitative research throughout this set of workshops. So go back and watch last fortnight's one. We've got correlational design. Now, anytime that you see the word correlation, it just means relationship. So correlation and relationship. So looking at the relationship between two variables. We've got our experimental designs, and the gold standard of experimental designs is our randomized control trials, where everybody has a equal chance of being in the intervention and the control arm of the study. Then we have our quasi-experimental designs, where it's impossible to randomize or immoral to randomize people into certain groups. One example of this would be, it would be extremely immoral to take a group of people, randomize them, give half the group large doses of heroin and the other group no heroin, and then measure their biomarkers of health. That would be completely immoral. Ethics would never approve that. It would be dangerous to your participants. So in a quasi-experimental design, we would take a population who was already doing that or experiencing that variable. So people who are already heroin users, we would use and look at their health biomarkers compared to matched control of same age, same sex, things like that. So there are research designs. It is super, super important before we analyze our data or collect our data to make sure that we have our research question and our hypotheses clear in our mind. I always recommend, when you start reading widely about your research and exploring the gap in the literature, to write your research questions on a piece of paper and stick them to your computer, and constantly be going back to your research question and your hypotheses, because it can get quite lost sometimes when we're deep in analysis. What were we actually asking, or what did we actually want to know? Because we can go down all these tracks of, oh, this is interesting, look what I found here, this is significant. But if those things don't match your research question, then you're doing what we call harking, or hypothesizing after the fact. So having these up front before you analyze is very, very important. So let's have a look at some research hypotheses. So in the chat box, I want you to provide your hypotheses about each of these research questions. So a hypothesis is a statement that can be tested, which we can use empirical outcomes. So changing a research question into something that is measurable, and we give a prediction of what we believe is going to happen. So for the research question, is there a relationship between diet quality and depressive symptoms in those who eat a plant-based diet? What would your hypotheses be for this research question? What would you hypothesize? Type into the chat box. Christopher Oliver, the null hypothesis is there is no relationship between diet quality and depressive symptoms. Good. So that is a very good point. So Christopher has written HO, which is the null hypothesis. We are always testing that there is no relationship when we are doing data analysis. We are never actually testing if there is a relationship. So when we put all of our numbers into SPSS, as we will do today, and it spits out an answer, it doesn't mean that the hypothesis that we are making about our research question has been proven. It always means that there is a chance that the fact that there is no relationship between diet and symptoms may be wrong or may not be true. So it's very, very important. Who wants to give me the alternative hypothesis to the null that Christopher has given? So Inna, there are less depressive symptoms in those who eat a plant-based diet. Close. There's a variable missing, And this is why this is very important, because it needs to be able to be tested empirically. So with Inna's hypotheses, we would be testing whether or not people who are plant-based have depressive symptoms or not. But there is another variable in that research question. Does anyone else want to have a crack? No, not the population. Can anyone see what the other variable is? Diet quality, good. So depressive symptoms are negatively associated with diet quality in those who eat a plant-based diet, says Albie. So when we say a negative association, we mean that as diet quality goes up, depressive symptoms go down. And this can be a little bit confusing because it sounds like a negative association means that the other way around, but it actually doesn't. So a negative association, as one variable goes up, the other variable goes down. A positive association is when one variable goes up, the other variable also goes up. So Albie is correct. Well, is he? We don't know. We haven't run the analysis yet. So what Albie has given us is a directional hypothesis. Now, I tend to not go into my research with directional hypotheses because you would only be able to test whether diet quality goes up, depression goes down. I want to test both. I also want to know if as diet quality goes up, depression might go up. I also want to know that. So I would look at a non-directional hypothesis in this case. That way you get to analyze both ends of the question. So for me, the research hypothesis would be there is a relationship between diet quality and depressive symptoms in those who eat a plant-based diet. Okay, do we want to try the research hypotheses for the second question? Do vegans or vegetarians have higher rates of depressive symptoms? What do we think the hypothesis is for this question? Does anyone want to give it a go? These are two very different ways of looking at the research question, but can both be analyzed using the same data set. Inna, there are higher rates of depressive symptoms in vegans or vegetarians? Very, very close. Albie, no difference in mean values of depression symptoms between groups. Good. Okay, so this research question isn't looking at relationships. This is looking at the difference between vegans and vegetarians. So we would split the groups into those who are vegan, those who are vegetarians, and we would hypothesize which of those do we believe have high rates of depressive symptoms. But this time, Albie has done a non-directional hypothesis. So no difference in the average of depressive symptoms between vegans and vegetarians. And that's your null hypothesis. Okay, good. So these are the actual variables that we will be using today in our data analysis. And this is a live data set that I have been recruiting for the last month, and it only was closed on Monday. So you are the first to see the analysis, which is very exciting. Now, another terminology that's really important before you dive into SPSS is your independent and your dependent variables. Can anyone tell me what the independent variable is? Psych honours students, I want to hear from you on this one. You should be all over this. Oh, good, Amy. We'll get to that in a second. But what is an independent variable? What determines the differences between the two? And what is a dependent variable? Good, excellent. So Amy has said An independent variable is a variable that can be manipulated. Now, that is the case in experimental studies. The independent variable is the variable that the researcher manipulates. But when we're talking about survey studies, the researcher is not actually manipulating those variables. Then they become the predictor variable. The independent variable is the variable that predicts the change in the other variable. So that's really important to understand. Henriette, dependent variable is the outcome. Good. So in experimental research, the dependent variable is the outcome. And in the survey style studies, the dependent variable is also the outcome. So the independent variable in survey studies is the variable that predicts the change in the outcome. And in experimental studies, the IV, the independent variable, is the one that is manipulated to make the change in the outcome. Excellent. So let's have a look at our two research questions. In the first one, which one is our IV and which one is our DV? Just making sure that you're really over the terminology and understanding the terminology before we dive into how the analysis works at SPSS is really important. And being able to identify which is the IV and the DV. Albie's got it. I'll let another couple type into the chat and see whether they agree. Does everyone agree with Albie and Henriette? And oh yeah, everybody's getting it. Okay. Good. Diet quality is the independent variable because it will predict the change in the depressive symptoms, which is the DV. Good. What about the second research question? What is our IV and DV in this circumstance? Does everyone agree with Albie? What's Albie got there? Yep, so the dependent variable's the same. Depressive symptoms, what's our DV, our IV, sorry? Albie's got it. So it's a little bit different when we're looking at differences between groups because the IV, the independent variable, becomes the group with two categories, vegan and vegetarian. So the IV really is plant-based dietary followers with two categories, vegan and vegetarian. Good stuff. Okay, the next thing that's really important to know before you dive into SPSS is your levels of measurement, because if you get these wrong when you are nominating what levels of measurement your variables are in SPSS, your whole analysis will be incorrect. So these are really important to get your head around and to understand. So the first category of variables that you can have in your data set are nominal. These are categorical variables where the categories don't have any order. So an example of this is gender. So we have female, male, transgender, non-binary, and other. Political affiliation, there is no order to the categories. Ethnicity, there's no order. So this is our very basic categorical data, nominal. Then we move on to ordinal. Now, ordinal is also a categorical variable, but the variables have an order. So think about like being ranked in a race where first and second, second and third, there is no, the distance between first and second and third are not the same, but they are in some form of order. So some ordinal data that we have: socioeconomic status, low, middle, high, level of education. Ordinal data can also be high school, bachelor's degree, master's degree, PhD, things like that are also. Fail, pass, distinction, high distinction, and credit are also ordinal because there is an order to them. Then we move on to our continuous data. So the two top ones are categorical, where things fall into a category. The second two are our continuous data. So interval data have a ranked order, but there are equal distances between each of the orders, and the data will lie on a continuum between negative infinity through to 0 up to infinity. So always think about a ruler when you're thinking about continuous data, with the 0 in the middle. Whereas our categorical data do not lie on that form of continuum, they're just categories. So interval examples are IQ in Celsius and degrees, but not in Kelvin, if anyone is still using Kelvin. Temperature. IQ is also interval data, so you can be ranked from 0 all the way up to whatever the top IQ is. And then we have our ratio data. Now, the difference between ratio and interval, they still lie on a continuum, but ratio data has a true 0, and there are equal distances between each notch, basically. So it has all the qualities of nominal, ordinal, and interval data, but a true 0. So what that means is when there is a 0, a true 0, that means at 0, there is none of that variable left. So with temperature, which is an interval variable, temperature can go underneath 0, and that does not mean that there is 0 temperature or no temperature. It means that temperature is negative 10 degrees, negative 20 degrees. Whereas with ratio, it means the true 0 means the absence of that. So height is a ratio, so you can go from 0 to whatever the tallest height is, but you can't, at 0, you have 0 height. You are no height. You can't be negative height. Income is the same. 0 income means no income. You can't have negative income. Curious about IQ being interval rather than ratio. I know, me too. Why is that on there? I'm going to ask Gail, who is my, who has also been running these workshops, why that is on there. I think you're actually right, Alice. I think it's a ratio. I will get back to you on that one. Okay, so let's have a try. I don't want you to answer these questions. I want you to tell me from 1 to 8, what type of level of measurement are they? So remembering we've got interval, ratio, nominal, and ordinal. So what is our number 1? Does everyone agree with Amy? Ooh, Albie doesn't. So we've got 2 different answers. It does look ordinal, doesn't it? They are categorical, but they seem to have an order to them. 18 to 29, 30 to 59, 60 and above. What about number 2? How many children do you have? Does everyone agree? Yeah, so ratio is a true 0. Good. Nice. What about number 3? What is your race? Good, excellent. What about 4? Four. Does everyone agree with Albie and Alice? Yeah. So how come number 1 was ordinal and number 4 was ratio, but they are kind of asking the same thing? They're just asking you how old you are. Good. Does have as true 0. Oh, it's okay, Alice. Okay, what about number 5? What is the highest level of school you've completed? Albie wins quick draw today. Good. Ordinal, we all agree with that. What about number 6? Interesting, isn't it? I don't think it's ordinal though. Can anyone see why? What's the difference between ordinal and interval? So the difference between ordinal and interval is ordinal is categorical with a ranked order. Yes, good, Amy. So interval actually is something that lies on a continuum that has the same distance between each of the notches or each of the categories. So Amy's actually right. That's an interval data. What about number 7? Yep, good. Nice. And number 8. What is number 8? It does look ordinal, doesn't it? But yeah, Louise, it might be interval because, well, we assume that there's equal intervals between the smiley faces, right? And the red, yellow, it's in the wrong order. Dark green, light green, orange, yellow. The orange and the yellow should be switched around, really, shouldn't they? But yeah, I think it's interval as well. Good. You guys are ready. You are ready for SPSS. Those are the main things that you need to know. And just please keep in mind, if you are going to do a PhD, do a master's thesis, do an honors thesis, please make sure you write your data analysis strategy before you collect your data. Otherwise, you could end up with data that's complete. A biostatistician or someone who will help you with the data, make sure you talk to them during the research design so that you're making sure that you are putting the correct answers into the correct questions into your survey that can be analyzable to answer your research question. Very, very important. All right, let's move on to data cleaning in SPSS. While I was doing honors, and I did, as I said, in psychology, you get this really great statistics training. One thing that I teach you is how to get your data actually into the program. And so you let out into the world with this wonderful data that you've just collected, and you're like, how do I make this data analyzable? I know how to do the analysis. That's what they taught me in class. But how do I get my data into the software program, and how do I clean it so that it can be analyzed? Yes, Alice. So Alice is just asking about interval and ordinal. So the difference is ordinal is categorical, and there is an order to the categories, but the difference between the categories is not even. So the difference between someone coming first and second is not the same as the distance between someone coming second and third. Interval is the same as ordinal, but with the same distance between the categories. And it lies on a continuum. All right, let's get moving into exporting data into SPSS, data cleaning and transforming our variables. So let's have a try. We will be using, well, I will be using 3 different platforms today: Qualtrics, Excel, and SPSS. This data I started collecting on the 20th of, no, it was earlier than that. This must have been it might have been. So maybe 3 or 4 weeks ago, we started recruiting vegetarians for life. So most of my research is on diet and depression. I've moved into looking at why vegans and vegetarians actually have higher depressive symptoms, even though their diet should be protective against depressive symptoms. So this is something that's really interesting to me, and I don't know why this is the case. So we decided, me and my research team, that we would look at people who have been vegetarians for their whole life, because we've got this whole confounding variable that people who are plant-based don't tend to start plant-based. They switch between omnivore and plant-based throughout their life, or they just started plant-based, or they've been plant-based previously and come back. So that's been messing our data up a little bit in the past, but we decided to look at populations of people who have been vegetarians for life. Now, we have a high Indian population in this data set because we were targeting people who religiously were born into families who were vegan due to religion. So there's lots of Indian participants, and there's lots of Australian Indian participants in this data set. It closed for analysis on Monday. So today is Wednesday, so it's only 2 days old. I've done a little bit of analysis while putting these slides together. Let's go and have a look at the data set. So the first thing that you need to do is export your data from Qualtrics. So if you're using Qualtrics or SurveyMonkey, it's a very similar process. Here's the actual data survey that we did. All you need to do is go up to Data and Analysis, close your survey, export and import. Now I'm going to show you 2 different ways of doing this. Depending on what software platform you use, you can export this into Excel first, clean your data in Excel, and then put it in SPSS, or you can put it straight into SPSS. Many different researchers have a preference. Neither is better or worse, but I'll show you how to do both of them. So this is the download table. Once you click the export and import button, click trying to remember which way around I did it. Save it. And then simply click to open the Excel. Can everybody see what I'm doing on my screen? Just make sure that it's not all hidden. Yep, good. Amy's asking, what about Jewish people? Yes, so we mainly targeted Hindu and Sikh populations, but then because it was snowballed across social media, we got a lot of people from, as you'll see in the data set, we got a lot of people from a lot of countries. So we got Canadians, we got people from the United Kingdom. So we got lots of people who have been vegetarian for their adult life. And I'm assuming a lot of them may have been in the Jewish religion too. All right, where is my Excel? What is happening? Okay, so when we open up Excel, it looks like this. But don't panic. When we clean our data in Excel, most of this stuff here, like the start date, the end date, the progress, that's how much of the survey the participant completed. Each row is a participant. Each column is the answer to their question. A lot of this can be deleted all the way up to this one here. So the reCAPTCHA code just makes sure that they were human, what language they were using when they did the survey, what date they recorded it. Sometimes people like to keep this box so that they know what date and time it was done. I get rid of it all and I start at question 1. So you can clean your data in Excel if you like, or you can clean it in SPSS. So I will show you that now. Again, when you open SPSS, you get something that looks like this. Don't panic. I'll show you how to clean it very easily. So we'll go back to Qualtrics and we will export our data into SPSS. Click download. Doesn't take very long. Open the folder, double click, wait for a million years for SPSS to open. It didn't do that for me because I opened it before we started because I know how long it takes. Okay, Amy has a really good question. Do you remove participants who have not done 100% of the survey? Now, this is where it's very important to work in a research collaboration with either your supervisor or other researchers, because you would not want to make that decision by yourself. In this case, I would remove the participants who haven't completed both the diet quality questions and the depression questions. So this is why it's very, very important to be strategic about designing your survey before you collect data. So you would always want to put your most important variable questions or the scales for those questions at the front end of your survey so that people who get bored or fatigued answer the important questions, and then maybe things that are like covariates like physical activity, sunlight exposure, social connectedness that aren't part of your actual research question, you don't lose those participants if they don't do, say, the last 20% of your survey. They've still answered the important questions. But I will show you, Amy, while we are going through this today, what my strategy would be for removing participants. And keeping in mind, you must always report your the amount of participants who completed your survey to begin with, and then how many you removed and why must always be reported in your results section. Okay, so this is what SPSS looks like. This is the variable view on the little gray tab down the bottom here. Now, the variable view is where you have control of telling SPSS what you want to do with each of the questions from your survey. You can turn them into variables, you can get rid of them, you can transform them into other different variables, and we'll go through all that. Now, in this case, as I said, all these variables here I would not use. So I wouldn't need the start or the end date. The progress, I'll look at that in a different way. The date it was recorded, the language, and the reCAPTCHA code. I don't need any of that. So I would shift and highlight all of those, and I would just clear them. Now, the most important thing about data analysis in SPSS is always save your raw data. So at this stage, before you remove anything, save your raw data, and then save the data again at each stage, especially after you remove variables or you remove participants. I made the big mistake of recoding my data for the depressive symptoms into itself and made a mistake, and then I had to start all the way back at the beginning again. So don't let that happen to you. Just save along the way and name them different files so you don't have to go back. Okay, so we would get rid of those ones and we would start with question number 1. Now, Qualtrics has transported all this in with the label is how you worded the question in your survey. But when you are producing analyses, you want this label to be whatever you want to see underneath your graphs and your tables and your figures. But it does help you to name your variables. So our very first variable, question 1, was, have you consumed a plant-based diet, vegan or vegetarian, your whole adult life? Now, this was a question to make sure the people who entered the survey actually fit our inclusion criteria. So we would go to the data view. Now, in the data view, you will see each question of the survey in each column, and each row is a participant's answer. Now, as you can see here, participant number 1 clicked no to have you been a vegan or vegetarian your whole life. Now, that disincluded that person from the survey. They would have been sent to a brief comment saying, thank you for attempting our survey. Unfortunately, you do need to be vegetarian for your entire life to complete it. Whereas person number 2 was a male, age 34, from the United States. He clicked yes, he has been vegetarian his whole life. So he then has all the answers for his survey in here. So what I would do for question number 1 is I would right-click on Q1. I would sort, I can't remember what yes and no was, sort ascending. Now, as you can see here, now that we've sorted ascending, we have all these little dots. These are people who opened the survey but did not complete it. Now, I'm assuming half of these are me or my research team when you go in and open the survey to get the link to send to your social medias or to other people. So most of this is probably the research team, to be honest. So we probably did that between ourselves 40 times. There was 3 researchers doing this. So we would just click on number 1, which highlights all the row. We would then shift and click number 40, right click, and we would cut those because there are no answers in there. There are no. Right. So that leaves us with all of the people who said, yes, they were vegetarian or vegan their entire life. Because yes, and see this little button up the top here, this will convert your word answers to the corresponding code that they have been labeled as. So all the yeses were 1s, all the nos were 2s. So we're interested in the nos at the moment. So we would right click on Q1, sort descending, and that gives us all the people who click no and were disincluded from the survey. Now, this is being recorded so you can follow along when you have a live data set yourself and you are doing your data cleaning. You can follow along and follow the steps that I'm doing now. So even though this seems like a lot of information to take in, the recording will be even more valuable once you are doing this live yourself. So for all the participants who were no for being vegan or vegetarians their whole life, how many of those do we have? We have 143 people who went into the survey, may not have read the recruitment correctly and weren't actually vegetarians for life. So we would highlight them all by clicking shift and left button, and we would click the right button and we would cut them from the survey as well. Now, it's vitally important at this stage to write down 40 entries of the 609 did not complete any answers. 143 were not vegetarians for life, and so were disincluded. So very, very important. So now in the data set, all we have is anyone who has been vegetarian for life. And that now leaves us with 426 participants. Now, when we did our G-Power analysis, which is a little calculator that you should do to determine how many participants you need to make sure your analysis has got enough people in it, we needed 219. So I always try and recruit double that, because as you will see in a second, we lose more people. So that's question 1 done. Now everybody in our data set is included. So I would then remove that variable from our variables. We don't need that anymore. It's done its job. It's told us who is and who isn't vegan and vegetarian. So I would get rid of that variable to clean up our data set. Now our second, yes, Alice, do you have a question? Why 219? So there is a calculator called G-Power online. Now this is really, really important that you do this before you collect your data. You go into G-Power, you tell G-Power, actually, I will send you all the download for G-Power, it's free. You go in, you tell G-Power what analysis you're going to do, how many independent variables do you have, how many dependent variables do you have that you would like to use alpha p-value of 0.05 and a moderate power of 0.8, which is what we always use. So they're always the same. And it will tell you how many participants you need to collect data from to make sure that your analysis has power or is has enough participants in it. So I will send that to you. All right, back to the data set. Okay, so variable number 2. What would we name the variable? So keeping in mind, SPSS only likes 1-word variables. If you want to use 2 words, you have to use an underscore. Amy, right, we're going to name this gender. Gender is a numeric variable. SPSS only works with numeric variables. It will not analyze string variables. For some reason, SPSS has labeled some of these, which are numeric strings. So you will make sure you go through each variable and make sure that it's correct. So gender is a numeric variable. I like to make all my widths 8, but that's just a tidiness thing. 0 decimal places because it's a what type of variable? When we look at our 4 levels of measurement, what would gender be?
Interval.
Are we sure? Nominal. So gender is categorical and it doesn't have an order. So then we would change our label to whatever we would like to see underneath a figure or table. So I would just put gender again. Now the values button on categorical variables is very important. I go into Qualtrics and I label these before I put the survey out, so it's easier for me during analyses. But if you haven't done that in your Qualtrics or your SurveyMonkey, you may have to make sure that these codes for each are correct. So we have here male as 1, female as 2. Anyone who was transgender is 3. Anyone who was other and would like to specify could do so. And there was 5, prefer not to answer. Don't worry about the missing column. That's from an old SPSS where you used to have to label all the missing data, but it does it automatically for you now. I also like all my columns to be 8. And I'll show you a tip and a trick on how to make them all 8 very quickly and easily in a sec. I like my alignment, and alignment is just where the words sit in each column. And again, you don't have to change these if you don't want to. I like everything to be centered. So here's a tip and a trick for SPSS. To make things faster for you, instead of going and clicking centered on every single variable, you can right-click, center, copy, then click on the top variable column, which highlights everything, and then right-click, paste. and that will make everything centered. So the same with your columns and your widths. You can right click, copy, highlight the whole column, paste. Now they're all 8. Same with width, highlight, paste. Now they're all 8. These things would have saved me so much time in honours. I spent weeks cleaning and analysing my data and going back and starting from the raw data again because I made mistakes and didn't save it. So all these little tricks will help you. Okay, so gender, where are we up to? Alignment. Now our level of measurement, is it correct? Let's have a look. What type of levels of measurement have we got? No. So we've got nominal. We know what that is, categories. So the little box helps you because there's a red, a green, and a blue category. And then ordinal has a little stepped up bar graph, which is categories in order. And then you've got scale. So they're our interval and our ratios because they're on a continuum. They're on a ruler from infinity to negative infinity with 0 in the middle. On a ruler. So it helps us determine. So it's not right. Which one should it be? Which one should gender be out of these 3? None. Good. Excellent. So we just make sure, because SPSS does not get this right. Always. Now, the most important thing to do after you have gone through and made sure that your variable is how you want it. So you're telling SPSS during this process how you want it to be analyzed. We go back to the data view and we clean that variable and we make sure that there's nothing weird happening. So we go to gender and it's been relabeled now. If you want to see the gender categories as numbers, you can click this little button up the top here and it will change it all to their codes. I like to work with them in their words. And we would right click and we would sort ascending. Oh no, what's happening here? So we've got a lot more missing data than we assumed before. Now, I wouldn't start removing these until I get to my IV and my DV. So I would just leave these as they are for now, work in the data set with this. It's around 50 people who haven't really completed the survey after clicking on it. But then we just want to go and check the gender column doesn't have anything weird in it that we haven't nominated. So we've got all our males, we've got female, then we've got transgender, and then we have other. Now in our other box, we also gave them the ability to answer what other, so to specify what other. Because I've changed the columns to 8, it has now cut off all of my words. So don't do the columns thing until at the end. This person wrote vegetarian as their gender, which is fun. So we would just change them to prefer not to answer. And then we have someone who was non-binary. So this was a oversight on my behalf when I was doing the survey. I should have put non-binary in and I didn't. So what I would do from this free text choice is I would go back into the gender variable and I would add non-binary to my answers. So I would probably make non-binary. I would just change. No, I'll do it not too confusing. I would make non-binary 6. Make sure you add the new category and click OK. And then I'd go back to my data view and I would change this person who has made a free text choice of non-binary to non-binary. And now this variable here, this free text choice variable, we don't need it anymore because there is no other text in there. So I would go into the variable view. Gender's looking really good. There's no anomalies or weird things happening with our gender variable. And I would clear that free text choice. Other, please specify. We don't need that anymore. Okay, so that is how to clean and transform kind of a categorical variable. Now let's work on a continuous variable. So what is this variable? What would we call this one? Okay, I'm just going to answer one question in here from Alice. So up to where there is missing data, did they all skip the gender question? Yeah, but these people here have skipped every question. There are no elements in here. However, participant number 6 skipped the gender question, but contributed some data on the rest of the survey by the looks of things. So for those 2 participants, I would also click prefer not to answer, because they have still given us data, and so is this person here. So I would probably give them prefer not to answer as well. They may come out in the wash when we look at the depression and the diet quality variables, but for now we'll put them as prefer not to answer because it does seem like they have answered some stuff. Right, age, let's go. So age, what type of variable do you think age is? Is it a string? String means words. No, it's numeric, isn't it? Now, the reason that SPSS does this is because participants were freely allowed to write their age. So it doesn't nominate that as numbers, it nominates it as words, but we'll tell it it's numeric and SPSS will be fine. No decimal points in age. People aren't going to say they're 40.5 years old. We would label it just age. Now, in your continuous variables, there are no categorical labels, so you don't need to worry about that box. Missing, we don't need. We've done all of these. It's changed my alignment for some reason. Is age nominal, scale, or ordinal? When we ask people to nominate their age in years, we've asked them to write their age in full years. Good, scale, because it's on a continuum. Excellent. So that variable was really easy. Let's go back to the data view and we'll go to age, and we will just have a look at our age variable and clean it and make sure it's okay. So let's sort descending. Uh-oh, what's happened here? What's going on with participant number 1? They've given you the year born. So we can, as researchers, figure out that how old would that person be if they were born in 2001? 22. So we can change that and not have to write it into our write-up. What about the person born in 1989? How old would they be? $34, good. Now, is it possible that someone could be 85 years old? Yep. So that's our oldest participant. So that seems like a reasonable age. If someone had written here 205, that's not a possible age range, really. So we would think about what we would do with that data. And there are certain things you can do. So our age looks pretty okay at the top end. Let's go and have a look at the bottom end. So we sort ascending. Again, we've got those 50 missing people. Well, there's only 45 now because we've put those other people back in. Now, here we have what I would assume is a bit of a problem. 1, 2, 3, 4, 5, 6 people have not nominated their age. That's fine. I don't mind. People are sensitive about age. It doesn't matter. Would you work out an age cut-up before sending the survey? Yeah, so usually you do a cut-off. We didn't really have ethics to survey people under 18, but we also didn't say in our recruitment drive that you had to be over 18. So I would need to talk to the head of ethics and just ask them if it's okay to include those who are these ones here who are between 12 and 16. So I need to have a word with my ethics head. another oversight on my behalf when I was doing recruitment. So there's always these little things that you can accidentally do. 12 and married. So that's a good point, Alice. Could this be someone who is malingering? Someone who is not telling the truth? Or is 12 a mistype? Good. So they've got a diploma as well. So we think that maybe this might be a mistype. The education level and age is not aligned. So they're 12, they're 182 centimeter tall, 182 centimeters tall, 102 kilos at 12. Live in Australia, they're married, they have a diploma. Probably not. So we would just maybe erase that data point. And then have a look at the other ones who are underage. So we've got a female, 13. She doesn't know how tall she is, so that sounds about right. She's single. That sounds like a genuine 13-year-old. Here's another 13-year-old who is 65 centimeters tall and 44 kilos from India, who is also single. And she's written other probably because she hasn't, the education level that we nominated as the highest was year 10. So they've put other here and then they've said they're a student. So that aligns with the age. Here's a 16-year-old, 164 centimeters tall, 45 kilos in Australia, whose highest level is year 12. Is that a possibility? Oh, you think that one might have been 21? Yeah, I think this is fine. Here's one, a female who's 16, 164 centimeters tall and 25 kilos. Maybe. Who has done year 12? That sounds about right too. Here's an 18-year-old who's 5'3", who's 50 kilos in Australia, is single, who's done a diploma. Yeah. So we would leave the rest of those. But the data cleaning is really making these decisions not by yourself. The project title includes adult life, less than 18 out automatically. Yeah, that's something that we have to discuss because originally the project was just vegetarian for life. But then we had a lot of backlash from people saying, well, I've been a vegetarian for my whole adult life and I couldn't make those decisions as a child. And so we decided to loosen the criteria to you can have been a vegetarian for your adult life. So it doesn't really rule out those who are 18. But I think that the ethical standards of the project may rule out those participants. I'll just have to make sure. So these are all very, very good questions and why we should never do studies by ourselves. Okay, so that's a categorical variable and a continuous variable. The next thing that I want to show you is, let's go back to our PowerPoint. There are our demographics. I've gone through and done all of them there, but I won't because that will take up too much time. The next workshop, I will share with you the whole data set, nice and clean, and we'll go through some of those. I want to teach you now how to compute a new variable. Now, to do this, I'm going to teach you how to create BMI from height and weight. And I've got my fingers crossed because my maths is not extremely good, so I have to make sure I do this correctly. Now, I'm just going to change these to numeric so SPSS doesn't get upset. So height and weight, we are going to use to create a new variable called BMI, which is not something that we asked because it's intrusive, right? Or people won't know. So we've got our height variable and our weight variable. Now to transform or create a new variable, we want to go to transform, compute variable. We want to name our new variable BMI, and then we want to create a label for it. So I would write something like body mass index. Nice. Remembering this label is what will be under your tables or your figures. Continue. Then we want to take, so BMI, the calculation for BMI is weight divided by height meters squared. So weight in kilograms divided by height in meters squared. Now, just quickly going back to our variables, what is weight measured in? Kilograms, so that's okay. What's height measured in? Centimeters. Good, Amy. So that's a problem because we have to convert centimeters into meters. So we can do that in our transformation. So BMI, and we want weight. Always make sure to click the little arrow to put it in. Weight divided by height put it in a bracket. Then we want to divide height by 100. So 100 centimeters, centimeters divided by 100 is meters. And then we want to square it. So to square in a transform box like this, you need to do 2 asterisks. I don't know if I want that many spaces. 2 asterisks and then a multiply. So you've got plus, minus, asterisk is multiply, double asterisk is divide, your slash is divide. So let's see if this works. I've got to put the label back in. Okay, now that has created a brand new variable. SPSS always puts it down the bottom here. So I always like to move my variables up to where they belong. So I would click on that and click and drag up to the top, and I would place BMI underneath height. Then I would go through, do the same process as we did before. BMI might be able to have decimal places. Let me have a look. Yeah. So you have to make a decision here whether you want BMI as a full number or as a decimal place. I like to keep it nice and neat. BMI is what type of variable? Scale, nominal, or ordinal? Scale, good. So it's continuous, so it doesn't need categorical variables. And it's scale, so that looks right. So let's go into our BMI variable and make sure that it's looking okay in our data view. So let's sort BMI descending, so highest BMI is first. Uh-oh. What has happened here? What is going on here? This, I can see, these people have put their heights and weights in weird ways. So this has got 2, 6, 5, 6, 5. That's weird. Okay, so before we calculated our BMI, we should have cleaned our height and our weight. Because what I think's happened here is people who have put in meters or foot. I did see before people had 5'3", but that's all disappeared now because I've changed the variable and calculated it. So that's what's happened. So this is a really good example of why we need to go through systematically every single variable, tell SPSS how we want it measured, go through, check ascending and descending to make sure each variable is correct before we do any form of analysis or any form of transforming. But these ones look all right. These ones from the top. So BMI is usually between 0 and maybe 60-ish. Anything under 18 is So these ones here. And I'm assuming these will be all our young people. Anything under 18 is underweight. Anything between 18 and 25 is normal weight. Cool. So that's how you transform a variable or create a new variable. The next thing that I want to show you. Now, is there any questions? Yes, there is. Okay. Amy's saying different country understanding of the question. Yeah, people putting in feet and inches, people putting in meters, despite the fact that the question said, how tall are you in centimeters? Yeah. So even when you write specific things like that, Alice, like making sure that the height question had how high are you in centimeters, people will still do crazy things. And that's what the whole data cleaning process is. It's making those judgment calls about what people did, why they did it, and things like that. All right, so we've got 38 minutes, which is good. We're going good for time. The next thing that I want to show you, that's how you do your demographic variables, and they're really, really important. The other demographics we've got is we've got geographical location, and we may come back to this one actually if we've got time at the end. But geographical location, we ask people just to write what country they were from in free text. So we've got quite a mixed bag of random things that people wrote. United States, United Kingdom, USA, but see how they're all written differently? So what we would do in this case is, because we didn't really know what countries people were going to be from, we just asked them to a free text, and we would create a categorical variable with the most common countries and label all of these. And maybe I'll show you that at the end. So what's another country that we've got? The country, we've got marital status, we've got highest level of education attained. So that's another one that's categorical and has the categories, but we gave them the opportunity to write other. So we, again, with the same with gender, we can go through, and anyone who wrote other, so let's have a look at that. So we've got people who wrote things like 2 bachelor degrees, students. So this is a student who must be under year 10 because we gave year 10 and year 12. We've got masters, we've got a doctorate. So we would just put these in where they match here. So like this person who wrote doctorate, I would put them into, I would put them as PhD. So just this person who says bachelor, I'd pop them in bachelor. Any of the students who are under year 10, I would just put them as year 10. Or I would create a new variable if I've completely missed one. Cool. All right, so let's just have a look. So the next tricky thing that happens when you've got a data set is you have created a group of questions to measure your variables to answer your research question. Now, our research question is about diet quality and depressive symptoms. So my first battery of questions here are the Centre of Epidemiological Studies for Depression Scale. The questions, there are 1 through to 20 questions measuring feelings of sadness or depression. So I was bothered by things that usually don't bother me. I do not feel like eating. My appetite was poor. I felt I could shake off the blues. I felt I was just as good as other people. I felt depressed. I felt hopeful about the future. Now, some of these questions are reverse coded to kind of figure out if people are just clicking the one button the whole time. So this battery of questions, how do we use those to analyze one variable? And when I did my honors, I was like, what do I do? Right. So Amy's saying reverse code the variables. So we've got to reverse code ones that are measuring the opposite of depression. So I felt I was just as good as other people would be reversed. I feel hopeful about the future would be reversed. I was happy. I enjoyed life. These are all ones that would need to be reversed. So here is the most important thing when you are transforming your questions into a variable you can analyze is to make sure that you go to the scoring paper for that variable and make sure that you're doing it correctly. The first thing to check, and Qualtrics will trick you up on this, is to make sure that the variable is coded with the same Likert scale as what's in the paper. So in the CESD, rarely or none of the time is a 0. Some or a little of the time is 1. Occasionally or a moderate amount of the time is 2. And most or all of the time is 3. Scores on the CESD, because there's 20, range between 0 and 60. So if you take the 20 questions and one person has done 0, rarely or none of the time for all of the questions, they would get a total score of 0. If someone had written most or all of the time for every question, they would click 3 for every question. They would get 60 if you times that by the 20 questions that they have answered. So the first thing is to go into the variables and ensure that the Likert scale is correct. So going into our values box, can anyone tell me what is wrong here? 6. What does 6 mean? 6 is wrong, right? So that should be a 3. So for some reason, even though I went in and coded this all in Qualtrics, Qualtrics has thrown a 6 at me for some reason. So I would go into our data view. What question was it? Question 11. And for all of the question 11s, I would change, or I would sort descending. And I would change the box from words to numbers. And then I would change all the 6s to 3s. Copy, highlight, paste. Now you need to do that for every question. Sort descending, highlight. Whoa. There were a lot of people who scored highly on question 4. Wow. Paste. So you would go through and do that for each of the questions. I'm not going to do that now, just to save time, but you would do that for every single question. And then you would go into your value box and you would click on number 6. You would change the value of 6 to the value of 3, change OK. Then you would copy that, click and drag to all of the boxes for the CESD and paste so that they all come up the same. Now let's go and have a look at the data view. Click it back to question 11. And just make sure, yeah, so see the ones that we have changed, have all the 3s have gone to most or all of the time, but not for these ones. So let's just go and make sure that has happened here. Yeah, see, that's still showing as a 6 for some reason. Let's try that again. Oh, maybe I didn't copy properly. Paste. Go back into data view. Yeah, so now see all the ones that we have changed are showing most or all of the time, and they're 3s, but these ones that we haven't changed still have random 6s in them. So that will completely mess up your scoring if you leave them like that. So you have to make sure to go in and check that your Likert scale is correct. So that's the first thing. Now, the next thing that you do, going back to our, for items 1 to 3, 5 to 7, 9 to 11, 13, 15, 17, and 20, the scoring is 0, 1, 2, and 3. However, for items 4, 8, 12, and 16, and they were the ones that we nominated as being reversed, we will need to reverse code those. Otherwise, they will throw our score out as well. So this is how to reverse code a question. Any questions from you guys before we move on to this? I know this is all going pretty quickly, but you'll be able to watch the recording if you want to backtrack, fast forward, rewind, and go through things again. I am monitoring the chat box, so if anyone has a question, just throw it in there and I'll answer it immediately. Okay, so even though we've got 6s in our data set, it's not going to give me the correct answers now, but, or actually we better just make sure. Anyway, okay, so to reverse code, you go back up to transform. This is where we computed our variable before. We recode into different variables. Now, this is a mistake that I made the other day because I'm a little bit cocky. I recoded into the same variable. What that will do is reverse code the data and overwrite the current question. And people are always like, Megan, you should recode into a different variable. So you have the original one and the reverse coded one. And I'm like, nah. But then the other day I did recode into the same variable and did it wrong. And then I had to start from scratch, and I had already cleaned all the demographics and wasted about an hour and a half of my life because I had to go back and do it again. So always recode into a different variable so you don't lose that original variable. So in undergrad, when we did simple analysis, the lecturer would have already reverse coded all these for us. Yes, they would have. Or they would have used scales that didn't have reverse coded questions, but they are very, very rare because they're there for a reason. All right, so the questions that we want to recode are here in this box. Now, I always right-click and change the label, because at the moment it's just giving us, below is a list of, it's giving us the question that we wrote in Qualtrics and they're all the same. So right click, display variable names. Yay. So you can input your variables. So what did they say? It was question 4, question 8, question 12, and question 16 that needed to be reversed. So I would write, usually before I do this, I go through and name these all the variable that it is. So like CESD1, CESD2, CESD3, CESD4. So these are all our depression scales, right? Okay, so that's how I usually would do it. So when I've put in the ones that need to be reverse coded, I would then relabel each one like CESD4R, and that just tells me that that's the recoded variable. Then we click the button. Make sure you always click change, otherwise it won't, oh, which I did not do the first time. Always click change so that it changes the variable name. Why is that around the wrong way? Classic. I did it with this one too. Wow, what a day. All right. Then we click on old and new values. Now, our current values were 0, 1, 2, and 3. but these ones need to be reversed. So in value, the old value is 0. We then want to change that value to 3 so that they align with the other ones. So I am happy and I am depressed. If someone wrote a 0 and a 3, they would then align. So then you click add. Old value of 1, you want a new value of 2. An old value of 2, you want a new value of 1. And an old value of 3, you want a new value of 0. And then just triple check 0, 1, 2, 3, 0, 1, 2, 3, making sure that this is correct. And then continue. Okay. And then you'll find at the bottom of your variables, it's created a heap of variables for no reason. You've got your recoded variables. So I would shift, highlight them all, and then I would drag them and place them underneath each of the variables that they correspond with. Right. Now, with each of the variables, I would do the same thing that I did with my demographics. I would just go through and make sure they're correct. So CESD question is numeric, 0 decimal places. This was the question. I would leave the questions in there like this because these questions will not be analyzed in your data set. We are going to create a variable from all of these that will then be analyzed. So it's just good to keep the question in there so that you can see these for later. What questions were asked just in case you need to. None. Column center. Okay. What level of measurement should this be? This question. So we've got a Likert scale from 0 to 3. What measurement, level of measurement? Has everyone gone to sleep? Are you still with me? Scale. Why is it scale? But there's not. Is there the same distance between rarely or none of the time as some or a little of the time? Is there the same distance between occasionally or moderate and most or all of the time? Yeah, Alice is right. So it's very common for people to analyze Likert scales like a scale. That's not correct. They should be ordinal. The differences between those categories are not equal. So Likert scales are always ordinal. So I would click on ordinal, I would copy that, and I would highlight and paste all the way down to the final question. Just so that when we create our new variable, SPSS creates the variable correctly. Now, we can't analyze depressive symptoms just from these 20 questions. We need to create for each participant a total depression score. And back here, when we read the paper on how to score depression, it tells us that the possible range of scores is 0 to 60, with the highest scores indicating the presence of greater symptomology of depression. So we need to create that total score for each participant. We just add all of their answers to all 20 questions together, and that gives us their total score. So after reverse coding the questions, we then move to creating that depression variable so that we can analyze it. So to do that, we go back up to transform. Just make sure I'm doing this correctly. Yeah. Transform, compute variable. Now, this is a good feature that SPSS has, is that it keeps your previous command in your compute variable boxes and your transform boxes and your analysis. So if you want to come back and rerun an analysis that you've just done, it keeps that. That's a really handy feature. But when you are creating another variable or doing a new analysis, you must always remember to click the reset button. So this time our target variable is CESD, the Center of Epidemiological Studies for Depression, total score. Now, in the label, I like to write the full name of the scale. And this is just a little tip that I picked up after I finished my PhD or during my PhD. Instead of having to go back to the paper every time you analyze and being like, oh, how was that measured? I write it into my label so that I can just look at it when I've analyzed the data and it helps me. So I write Center of Epidemiological Studies of Depression scale, and then I put its acronym in. I will always write 20 because that's how many questions there were. Ranges between 0 and 60. So when you go to analyze, you know, if you've got a mean of or an average of 30 across your data set, you know that the range was between 0 and 60. So that makes the average more meaningful. Ranges between 0 and 60, higher scores equal greater depression. Now, this is going to be handy when you do things like correlations, because if your correlation is negative or your relationship is negative and you haven't written this on your analysis or on your label, you're like, wow, what's happening here? What direction does depression go in? So I always write kind of the direction and the range in my label, and it helps me later on when I do the analysis. And I'll show you that next week when we do correlations. Right, so to create the total score for the CESD, it's really simple. Again, right click and change these to the variable name. And then we just want to click question 1 and make sure you click the arrow plus, question 2, arrow plus, question 3, arrow plus, question 4, but the reverse coded question 4. So make sure you always use the reverse code, otherwise it'll stuff up your analysis. Plus question 5, 6, 7, 8 was reversed, 9, 10, 11, 12 was reversed, 13, 14, 15, 16 was reversed, 17, 18, 19, and question 20. Now that will give us a total score for depression. Now be very careful when you read the scoring sheets for scales, because some scales will create a total score like this, and some scales will give you an average score. So if that's the case, if the CESD was an average score, you would then divide that by the 20 questions to create the average. So just be very careful when you read and make sure that it's correct. Right. Then we click OK. And that creates for us right down the bottom of our variables. Too many variables. The CESD total. So that's the variable name. Center of Epidemiology Studies of Depression scale, CSD 20, ranges between 0 and 60, higher scores equal greater depression. It's continuous. We've changed our Likert scales, our ordinal scales, to a continuous number now because it ranges between 0 and 60. Is that correct? Is the level of measurement correct? Yep, good. All right. So then we will drag the CESD total and always keeping our data together up the top, because a lot of this is going to be not used. The questions and things will not be used in your analysis. So you want to drag all the questions that are analyzable up to the top. So above the CESD questions. There. No. Sunlight exposure can go up. Okay. Then we go into the data view, find our CESD total. I'm just going to get rid of those decimal places. And we want to sort ascending and make sure that our CESD total fits between 0 and 60. Now it's not going to. Why not? Four is correct. So that's greater than 0. But then when we sort descending, we've got someone who scored 61, but our total should be 60. What's happened? That's right. Those scores of 6 that we didn't change back. So over here, you can see these scores of 6. They're not correct. They should all be 3s. So they're inflating our score. The data isn't fully cleaned. Good. Excellent. So it's really good to go and do these checks, because yesterday when I was actually doing this live, this is what happened to me. I didn't go and check my questions, and I found out that the 6s were there because when I did the CESD total score, they were really high. And I was like, what? So doing these checks is really, really good and important. Now, going back to the data cleaning question and the missing data question from very earlier on, this is the stage where I would eliminate participants again. Some of these participants don't have scores. That's also weird. Oh, okay. I think I won't know why. Because we didn't relabel the reverse coded questions. So there you go. I missed a step. And I didn't go in and I didn't clean my reverse coded questions. So we want to make sure that we do this every time we create a variable as well. So go in, create a label for it. And then here, we need to tell SPSS what the categories mean. And it will be the opposite to what these ones are. So for some participants, it's created anomaly and not given them a total score. So just making sure when you go in and checking and double checking. And this is why it's really important to be constantly saving at different stages so that you don't, if you do make a mistake like this or something goes weird in your data set, you can go back to the previous stage that you're at and not have to go all the way back to the raw data. And keeping in mind that these things, if you make mistakes and you've done something wrong or something's not working, always go and ask someone in your collaboration or your co-author, but also realize that this happens to us all. Every time we do data analysis, something weird, an anomaly will happen, some strange things happen. So just keep that in mind. Do we have time, Alison, for one final thing? You're on mute.
We've got 10 minutes.
Okay. So I might just show them what we did for country, what to do for country. So we asked a free text for country. What country do you live in? So we need to create a variable for, where is it gone? Oh, here it is here. So to do that, we go into variable view and underneath what country do you live in? So we clean the country one first, country, and That's just free text. We want to right click and insert variable. So we can create a variable in the data set from the screen as well. So here we would like choose country, numeric, no decimal points, country again. And then in the values box, we want to create the countries that we saw. So one for Australasia. So Australia and New Zealand, we put together. 2 for India. 3 for United States, I would assume would be the next largest. 4 United Kingdom. 5 Europe. 6 Canada, I think was in there. Okay. And then we would go back to our data set and we would sort descending so that they're all in line. And then what was USA? What did we say was USA? It was 3. So we would click on United States, copy, drag it all the way down to where United States stops, paste. Then with the United Kingdom, same thing. Copy, making sure that they are. That one probably isn't. United E, who knows? India. So, like I said, when you let participants have free text or free reign, lots of interesting things can happen. And just go through and nominate each of these. Now, here we've got the Netherlands. So the Netherlands is in Europe, I think, hope. Thailand doesn't fit into any of our categories, so we'd have to make a decision on where we would put Thailand because there was only one. Spain, so we'd have to put South America in there. We've got some African countries. New Zealand, we pop into Australasia. But these are all judgment calls that you can make yourself with your team, how you want to do things. I also like for marital status, so this one here, I like to create a variable. So we've got widowed, divorced, we've got married, we've got single, we've got registered partnership, we've got de facto. I like to transform this variable into partnered and unpartnered. So I just create a new variable, and anyone who's widowed or divorced or single, I would pop as number 1. And anyone who's married de facto in a partnership, I would pop in as 2. And that makes it easier to analyze. So you can make all these decisions yourself. It's completely a judgment call. Same thing with the vegan, vegetarian variable. We allowed people to self-identify as flexitarian, pescatarian, lacto-ovo, lacto, vegan, semi-vegetarian, but then we created a whole new variable and we would nominate them as vegan and vegetarian for ease of analysis. So sometimes it's good to let people self-identify the way that they want to, and then you manipulate the variable to how you want to analyze it. All right.
Excellent.
So next time we will be taking this same data set and we will be running descriptive statistics on the demographics. So all those demographics we were just looking at in this live data set: age, gender, country of origin, vegan or vegetarian. We'll be running demographic descriptive statistics, and I'll show you how to interpret those and write them up. And then I will also be showing you how to run a correlation or a relationship analysis on depression and diet quality. So all of those, when you come back next week, all of those variables will be completely clean and ready for analysis. And we'll do correlations, and I will run a t-test between the vegans and vegetarians to answer that question about which ones have higher depressive symptoms.
Great. Thanks so much. There's some great comments there. People have learned a lot.
It was very fast and very quick, but it's really good to use the video when you're actually doing it yourself.
Yeah, absolutely.
And if you have any questions,
Yes, very
at
smart
all,
bunch.
feel free to email me if you are doing data analysis at any stage. I also offer data analysis services. So if you have something that's completely tricky or advanced and you feel like you can't do it yourself, I do data analysis for a fee as well. So, and that's through the SCPA. So you can also contact the SCPA and or myself privately. Either way.
Thank you so much, Megan. There's one more question in there.
How is the rating of the smiley faces different to some of the time or all of the time? So the rating between the smiley faces was, there was a equal distribution between the 5 faces, we are assuming. But a Likert scale, such as the CSD depressive symptoms, doesn't. Good question.
Any other questions? We've got a couple of minutes.
Yeah, and that's the tricky part about survey analysis in itself. That's a limitation, is that 3 or 4 people can click the same answer on a survey and have completely different reasons for it. And that's why I highly recommend doing mixed methods research and having qualitative questions in your survey, or completing a survey, conducting a survey, and then going and doing interviews or focus groups.
There was just one quick comment when you were doing countries, and there was a United E. Albie thought of it too, so did I, as United Emirates.
Yeah, and
Possibly.
you would make that judgment call.
Yeah.
Pop them into the, I think I had a category for Middle East that we popped them into.
Yeah. It's hard to know if it's a typo or they actually meant Emirates.
Yeah, which is great. But again, it's all about the researcher's judgment.
Yes. Yes. Great. Excellent. Thank you so much, everybody, for attending. And thank you, Megan, for your expertise.
Thank you.
I'll just stop recording now.